Most head-mounted virtual reality displays have a horizontal field of view of around 100 degrees, which pales in comparison to the human visual field of more than 180 degrees. This makes the VR experience more akin to looking through binoculars, limiting the sense of presence in the virtual scene. We present the concept of sparse peripheral displays, which augment the field of view of a head-mounted display with a low-resolution, low-weight, inexpensively produced array of LEDs around the central high-resolution display. Our virtual reality prototype, called SparseLightVR, extends the standard Oculus Rift DK2 prototype with a set of 70 peripheral LEDs, creating a 170-degree horizontal field of view. We also implemented an augmented reality version called SparseLightAR, which is built upon a custom modified Galaxy Gear VR prototype. SparseLightAR is an untethered device which extends the horizontal field of view with 112 peripheral LEDs, creating a 190-degree horizontal field of view. Sparse peripheral displays provide additional contextual information, increasing the situational awareness of the person wearing the display. To render the color of each LED, we designed a series of matching light probes that can be deployed in any Unity game engine scene. Using SparseLightVR, we conducted 2 user experiments to evaluate the effectiveness of sparse peripheral displays. In the first experiment, we compared the participants' performance in a simple search task on 3 conditions. Using a narrow 50-degree field of view, similar to most augmented reality devices, using a standard 100-degree field of view Oculus Rift DK2 virtual reality headset, and using a 170-degree SparseLightVR hybrid display. In our visual search task, the SparseLightVR display significantly outperformed the lower field of view displays. Our second experiment investigated the effects of different visualization schemes in the periphery, and their effect on simulator sickness. The task required the users to follow an orb in the scene using a controller. We compared an unmodified Oculus Rift DK2 setup with our SparseLightVR setup, configured to render an extended field of view. We also compared a novel visualization called peripheral countervection motion, which creates a motion effect in the periphery opposing any motion that does not directly originate from the person's head motion. 11 out of 14 participants indicated that the peripheral countervection motion visualization reduces the effects of simulator sickness in our task, and both SparseLightVR conditions were preferred to the standalone Rift display. Please see the paper for more details. In summary, our sparse peripheral displays are an inexpensive, lightweight solution to extend the field of view of a head-mounted display and can increase presence and reduce the effects of simulator sickness.